Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about significance tests for means. Now you will recall from our previous videos that when you run a hypothesis test, there are 4 steps. The first step is to define the parameters and hypotheses. The second step is to check conditions, and please remember that MATLAB is very poor on emphasizing this step, but it's very important. Step 3 is run calculations. And step 4 is to write out a conclusion. Previously, when we talked about conditions for proportions, we mentioned that you have to have random sampling, and that doesn't change here for means. Remember that hypothesis testing is comparing the results we got from our sample to what could happen randomly. Now, as far as normality goes, we need the sampling distribution to be approximately normal. For means, there are 3 separate ways that we can justify the sampling distribution is approximately normal. The first one is that the population is normally distributed. In any population that's normally distributed, the sampling distribution of any size from that population will result in an approximately normal distribution. The second way that we can defend normality is with the central limit theorem. Remember that if n is sufficiently large, and in our case we're using 30 as a cutoff, so if our sample size is at least 30, then regardless of the shape of the population's distribution, the sampling distribution will be approximately normal. And the third way we can talk about this is using a normal probability plot. Now, these are used when we have a small sample size. If the first 2 ways of defending normality do not hold true, if we don't know the population distribution and our sample size is less than 30, then what we have to do is we have to use a normal probability plot of our sample to defend that the sampling distribution could be normally distributed. And I will show you an example of that a little bit later in MyMathLab. But for now, let's jump over and work on some examples. Okay, looking at problem number 2 from the 8.3 homework here, it says that the claim is that for a smartphone carrier's data speed at airports, the mean mu equals 19 megabytes per second. They took a sample of size 14 and they got a test statistic of t equals 2.119. Now, I want to pause for just a second and note that this is a t-test statistic and not a z-test statistic. You will recall when we talked about confidence intervals that because we don't know the population standard deviation, we have to use the t-distribution instead of the z-distribution when dealing with means. Given this information, they want us to find the p-value. So let's head over to StatCrunch. They tell us that we're dealing with a t-test statistic. So we're going to go to stat calculators and then the t calculator. And it says we had a test statistic of 2.119. So we're going to put in here 2.119 for our t. Now it asks for a degrees of freedom. The degrees of freedom are always 1 less than the sample size. So our sample size was 14. So we're going to type in 13 for our degrees of freedom. And looking at the problem, it doesn't indicate if they thought it was less than or greater than. They just wanted to know if it was different. So here I'm going to hit compute. You'll notice we're going towards the mean here. So we want to go away from the mean. So I'm going to switch this to a greater than. And we get that this area over here in the tail is 0.0269. Now, since we're doing a two-tailed test, we have to double that area in order to find our actual p-value. So in your calculator, you can say 0.026959 times 2, and you get 0.0539. So let's go back over here. It says 3 decimal places. So I'm going to type in 0.054. I can hit check answer. We got the right answer. Nice job. Now remember, it's because we're doing a two-tailed test here that we doubled that tail area. If this was just a one-tailed test, let's go back over here to StatCrunch. If it was just a one-tailed test, this would be the entire p-value. Since it's two-tailed, we're going to use the area on the right, but we also want to know if it can be that value or more extreme to the left. So we double this area to get our actual p-value. Okay, let's jump ahead to problem number 4. Reading through this, it says the display provided from technology available below results from using data for a smartphone's carrier data speed at airports to test the claim that they are from a population having a mean less than 5 megabytes per second. Conduct the hypothesis test using these results. Using a 0.05 significance level, identify the null and alternative hypotheses, test statistic, p-value, and state the final conclusion that addresses the original claim. All right, let's click on this informational display here. And this is an output. It looks like it's an output from a calculator, like a TI-84 calculator. Here it tells us that we're testing if the mean is less than 5. We get a t-test statistic. We have a p-value, an x-bar, a sample standard deviation, and a sample size here. So let's close this for a second, our hypotheses. Remember, the null hypothesis is always an equals to, so we can toss A out right away because it's not an equals to. And they told us that we're testing for it to be less than 5. So we're going to select C here because the null is equal to 5 and the alternative is that it's less than 5. So we're always testing to see for that alternative. Let's check our answer. We got it right. That's awesome. All right, test statistic. Let's go back to our output here. Negative 0.14. Negative 0.14. That's our test statistic. And check my answer. It says nice job. Identify the p-value. It's right here. 0.44, and it wants 3 decimal places, so we're going to put another 4 on there, and we're going to check that answer. That's good. State the final conclusion. All right, I'm going to close this display. Now, we're going to say we're going to fail to reject. The p-value here is larger than our significance level of 5%. So we're going to fail to reject the null. There is not sufficient evidence to support the claim that the mean is less than 5. Let's check that answer. Awesome. Now, if the p-value had been less than 5%, then we would have rejected it because there would be sufficient evidence. All right, I want to jump up here to problem number 7 next and work through that with you guys. So we're told here a data set includes data from student evaluations of a course. The summary statistics are n equals 99. Our sample mean x bar is 3.91. Our sample standard deviation S is 0.57. And they want us to use a 10% significance level to test the claim that the population of student course evaluations has a mean equal to 4. Assume that a simple random sample has been selected, identify the null and alternative hypotheses, test statistics, p-value, and state the final conclusion that addresses the original claim. Okay, so let's look at our null and alternative hypotheses here. Again, we can toss out A right away because it says the null is not equal to. In the problem itself, it does not say if we think it's less than 4 or greater than 4. It's just saying that we're going to test to see if it's equal to 4. So we're going to select D here, for the null is equal to 4 and the alternative is not equal to 4. This will be a two-tailed test. Awesome, got that one right. Now, it wants us to find the test statistic. Before we do that, when you run a significance test, the second step should also always be the conditions. It did mention that it's a simple random sample, but it didn't say anything about normality. However, our sample size is greater than 30, so the central limit theorem would apply here. So if you were running a test like this, and for perhaps a project at the end of the semester, or for another class, or at your job, you would want to mention that that condition is met. Now, to find the test statistic, we're going to go back to StatCrunch again here. And we're going to go to Stat. And instead of calculators here, we're actually going to go to T-Stats. and we just have one sample, and it didn't give us the data, it gave us the summary statistics. So we're going to hit with summary. Now, up here, it says our sample size is 99. So I'm going to type that in here, 99. Our sample mean was 3.91. And our sample standard deviation was 0.57. I'm going to just type those in there. Down here, I have to set my hypotheses. We said the hypothesis, let's lower this a little bit here, sorry, was that it equals to 4 or is not equals to 4. So I'm going to type that in here. The null is that it equals 4. The alternative is does not equals 4, so that's already set. And then I can go ahead and hit compute. Let's do a p-value plot just for fun. Compute. Now it gives us all the good stuff here. Our t-stat and our p-value, our degrees of freedom, the sample mean we already knew. So let's go ahead and type the test statistic in here, negative 1.57, negative 1.57. Check that. And it likes it. That's really good. Determine the p-value. Again, the p-value is 0.1194. 0.11, and they went 3 decimal places, so 119. Check answer. Then they want us to make a conclusion over here. Going back to StatCrunch, I want to emphasize for a second this p-value plot. Now, what we did is we took a sample and we got a sample mean that fell this many standard deviations away from the mean. So the probability of getting our sample's results or something more extreme to the left is represented by this red area here. The probability of getting our sample's results or something more extreme to the right is represented by that red area here to the right. If we want to look at the total probability of getting our results or something more extreme, we would add those two together since it's a two-tailed test, and we get that p-value of 0.1194. Let's go back here. So we're going to say, hey, this p-value, the probability was more than 10%. We're going to fail to reject the null. There is not sufficient evidence to suggest that the original claim, to conclude that the original claim that the mean of the population of student course evaluations is equal to 0.4 is not correct. Let's check our answer. We got that one correct. Nice job. Okay, the last problem I want to work with you guys is number 11. And this problem's a little bit different because it just gives you the data instead of the summary statistics. So let's read through it together. A group of students estimated the length of 1 minute without reference to a watch or clock, and the time seconds are listed below. Use a 0.05 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. Does it appear that students are reasonably good at estimating 1 minute? So here's our data down below. Now, it wants us to test the claim that from a population with a mean equal to 60 seconds. It does not tell us anything about it being less than 60 seconds or greater than 60 seconds. So here, our alternative is going to be a not equals to, and the null is going to be an equals to 60 seconds. So C is going to be our null and alternative hypotheses. Check answer. Awesome. Now they want us to run the test statistic. I want to pause here and talk about conditions. First off, it doesn't say anything about it being a random sample, so we have to assume that they did a good job of random sampling. Secondly, as far as normality goes, we need to look at this data in StatCrunch because there are less than 30 values in our data set, so the central limit theorem does not necessarily apply. So we want to go and do a graph, and we're going to do a QQ plot. This is a normal probability plot, and we're going to do it on our data itself. We want to compute, and you can see here we get a fairly linear pattern. It's not perfectly linear. This is a small data set, so we can't expect it to be too perfect, but we could say because the data is fairly linear that the sampling distribution could be normal. This is the kind of thing you would want to mention if you're doing a project at the end of the semester, or perhaps performing a test like this for another class. All right, let's close that and go back to the problem. It wants us to find the test statistic and probably the p-value next. So in StatCrunch, we have our data here. We're going to, again, do a t-stat, one sample, but this time we have the data. It's not summary statistics. So we're going to select with data. We will select our data list, variable 1. And then for our hypotheses here, we're saying that it equals 60 or does not equal 60. So I can adjust those. If we were doing a one-tailed test, I would say greater than or less than, just to show that. But we're not. We're just doing a not equals to. So I can hit compute here. And it gives me my test statistic and my p-value and all the other good stuff. So my test statistic ends up being 0.55. So let's type that in here, 0.55. Awesome. Our p-value is going to be 0.591 if we round to zero, or, sorry, if we round to 3 decimal places, 0.591. Is that what I just said? And I have to go check. I forgot already. Yes, 591. We can check that answer. Okay, our p-value here compared to our significance level. Our p-value is greater than 5%. So we're going to fail to reject. There is not sufficient evidence to conclude that the original claim that the mean of the population of estimates is 60 seconds is not correct. It does not appear, or sorry, it appears that as a group, the students are reasonably good at estimating 1 minute. Let's check that answer. Okay, those are all the examples I want to do with you for today. Remember, as you're working through the problems, if you have questions, please use this Ask My Instructor button over here to ask me questions. Thanks for joining me. Have a great day.